Good day, math learners. This time, we will be dealing on the exponential function. But before that, let us have to know the things that we will be talking for this week. So we have exponential function, and it includes the basic concepts, exponential equations, exponential inequality, graphs, and its applications. But in this video, we will just focus on the basic concepts, exponential equations, and exponential inequality. So the learning objectives for you math learners are to differentiate and define exponential function, exponential equation, and exponential inequality, and solve problems involving exponential functions, equations, and inequalities. For the information of everybody, as an expression, we know by definition that x squared is a polynomial. Remember that polynomials are expressions where the variables take on only whole numbers for exponents. Hence, we call the f of x is equal to x squared as a polynomial function. Such a function is also known as power function. A power function is in the form of f of x is equal to k x raised to n, where k is equal to all real numbers and n is equal to all real numbers and serve as an exponent. In a laboratory, findings show that the number of bacteria in a certain culture upon reaching maturity divides itself into two after every hour. To determine the number of bacteria present in T hours elapsed is represented by the formula f of t is equal to 2 raised to t. This function 2 raised to t is an example of exponential function. When we say exponential functions, they are functions of the form f of x is equal to a raised to x, in which the base a is a positive real number other than 1 and the exponent is a variable. Since a is greater than 0 and a is not equal to 0, then there is no value of x that will make the function less than or equal to 0. It doesn't matter what the value of x is, because the value of f of x will always be positive. In general, the f of x is equal to a raised to x is increasing as x increases. The domain will be the set of real numbers and its range will be the set of positive real numbers. So, this time, we will have a drill on determining the given function represented by its equation is considered as an exponential function. For example number 1, the function y equals 3 raised to x. Is that an exponential function? Yes, it is an exponential function because the base there is 3, which is a positive real number, and the exponent is a variable. For example number 2, the function y equals 2.5 raised to 2x. Is that an exponential function? Yes, it is an exponential function because the base there is 2.5, which is a positive real number, and the exponent is 2x that has a variable. For example number 3, the function y is equal to x raised to 7. Is that an exponential function? No, it is not an exponential function since the exponent is 7 and it is considered as a fixed value. For example number 4, the function y is equal to negative 3 raised to x. Is that an exponential function? Okay, no. This is not an exponential function because according to the definition of the exponential function, the base of the function should be a positive real number, and in the given, it's a negative number. That makes it not an exponential function. So those are the things that we consider in determining the exponential function. So this time, we will now be dealing with exponential equation. When we say exponential equation, it is an equation involving exponential functions of a variable x, which occurs as exponent. The goal in exponential equation is to find a value or values of the variable for which the equation will be true. Exponential equations are in the form a raised to x is equal to b raised to y. To solve exponential equations with same base, use the property of equality of exponential functions, which states that if b is a positive number other than 1, then b raised to x is equal to b raised to y if and only if x is equal to y. In other words, if the bases are the same, then the exponents must be equal. For example number 1, solve and check the given exponential equation 2 raised to x equals 16. Here are the solutions. Copy first the given. Make the bases of the expressions being equated here the same. We have 2 raised to x and 16. Since 16 has an exponential form of 2 raised to 4 because when you multiply 2 by itself in 4 times, the answer is 16. And then copy 2 raised to x equals, then change 16 to its exponential form, which is 2 raised to 4. Since the bases here are the same now, we will use the property of equality of exponential function in which the exponents of the same bases should be equated, and it is x is equal to 4, and 4 is the answer. For the checking, we are going to copy the given equation, substitute the value of x that makes the equation a true mathematical statement. So we have 2 raised to 4 equals 16. Simplify 2 raised to 4, that is 16 equals 16. So meaning to say that this equation is a true mathematical statement. For example number 2, solve and check the given exponential equation 4 raised to 2x minus 1 equals 64. Here are the solutions. First, copy the given. Make the bases of the expressions being equated here the same. We have 4 raised to 2x minus 1 and 64. Since 64 has an exponential form of 4 raised to 3, because when you multiply 4 by itself in 3 times, the answer is 64. And then copy 4 raised to 2x minus 1 equals, then change 64 to its exponential form, which is 4 raised to 3. Since the bases are the same now, we will use the property of equality of exponential function in which the exponents of the same bases should be equated, and it is 2x minus 1 equals 3. So simplify them further by isolating the variable x. So transpose negative 1 to the other side of the equation and it will become 2x is equal to 4. Divide 2 both sides of the equation and then x is equal to 2, and this is now our answer. For the checking, we are going to copy the given. After that, substitute the value of x, which is 2. So we have 4 raised to 2 times 2 minus 1 equals 64. Simplify them further, and it will become 4 raised to 4 minus 1 equals 64. We have 4 raised to 3 equals 64, and 64 equals 64. That makes this equation a true mathematical statement. For example number 3, solve the given exponential equation 10 raised to 1 minus x equals 10 raised to 4. Here are the solutions. Copy first the given. Since the bases here are the same already, we will use the property of equality of exponential function, in which the exponents of the same bases should be equated, and it is 1 minus x equals 4. Simplify them further by isolating the variable x. So transpose 1 to the other side of the equation, and it will become negative x equals 4 minus 1, and it will become negative x is equal to 3. Since we still have negative in our variable x, we will divide both sides of the equation by negative 1. So our answer will become x is equal to negative 3. For example number 4, solve the given exponential equation 16 raised to negative x equals 1 over 64. Here are the solutions. First, copy the given. Make the bases of the expressions being equated here the same. We have 16 raised to negative x and 1 over 64. One of the laws of exponents, particularly the negative exponent law, that for every 1 over a is equal to a raised to negative 1. Therefore, for every 1 over 64, it is equal to 64 raised to negative 1. So our equation becomes 16 raised to negative x equals 64 raised to negative 1. Since 16 has an exponential form of 4 raised to 2, because when you multiply 4 by itself in 2 times, then the answer is 16. And 64 has an exponential form of 4 raised to 3, because when you multiply 4 by itself in 3 times, the answer is 64. So our equation becomes 4 squared raised to negative x equals 4 cubed raised to negative 1. Then simplify the exponents there. So 4 raised to negative 2x, because 2 times negative x, the answer is negative 2x, equals 4 raised to negative 3, because 3 times negative 1, the answer is negative 3. So the bases here are the same. Then we are going to use the property of equality of exponential function, in which the exponents of the same bases should be equated, and it is negative 2x equals negative 3. Then simplify them further by isolating the variable x. So divide both sides of the equation by negative 2, and the answer is x is equal to 3 over 2. So this time, we will proceed now to the exponential inequality. When we say exponential inequality, it is an inequality in one variable having a variable in the exponent. The principle used in the property of equality for exponential equation, together with the rules in solving inequality, is extended in solving exponential inequality. So let's have a recall on the concepts of the inequality here this time. If we have x plus 2 is greater than or equal to 5, we have to isolate x by transposing 2 to the other side of the inequality. And it will become x is greater than or equal to 5 minus 2. And the inequality becomes x is greater than or equal to 3. The value of inequality is not changed. If we graph the solution set of the inequality on the number line, 3 here is shaded and the solution set is going to the right. For number 2, if we have 2x minus 2 is less than 6, we have to isolate x by transposing negative 2 to the other side of the inequality, and it will become 2x is less than 6 plus 2, and the inequality becomes 2x is less than 8. Then divide both sides of the inequality by 2 so that x will be isolated, and x is less than 4. The value of inequality here is not changed. If we graph the solution set of the inequality on the number line from 4, which is not shaded because it is not included as part of the solution set, and the solution set is going to the left. For number 3, if we have 2x minus 5 is greater than 3x plus 2, we have to isolate x by transposing negative 5 to the right side of the inequality, and 3x to the left side of the inequality, and it will become 2x minus 3x is greater than 5 plus 2. Simplify them further. 2x minus 3x, it is equal to negative x, and 5 plus 2, it is equal to 7. So our inequality is negative x is greater than 7. And then we will divide both sides of the inequality by negative 1 in order for the variable becomes positive, and the inequality becomes x is less than negative 7. The value of inequality here is changed. If we graph the solution set of the inequality on the number line, negative 7 here is not shaded because it's not part of the solution set, and the solution set is going to the left. For example, solve the exponential inequality 2 raised to x plus 1 is greater than 32. Here are the solutions. Copy first the given, make the bases in the inequality the same. We have 2 raised to x plus 1 and 32. Since 32 has an exponential form of 2 raised to 5 because when you multiply 2 by itself in 5 times, the answer is 32. And then copy 2 raised to x plus 1 is greater than, then change 32 to its exponential form, which is 2 raised to 5. Since the bases are the same now, we will use the property of inequality of exponential function, in which the exponents of the same bases should be considered, and it is x plus 1 is greater than 5. Then isolate the variable x by transposing 1 to the other side of the inequality, and it will become x is greater than 5 minus 1. Simplify them further, and x is greater than 4. So the solution set is x is greater than 4. To graph the solution set on the number line, okay, locate 4, and it must not be shaded because it is not part of the solution set. Then the solution set is going to the right. Therefore, the interval notation is 4 to positive infinite number, or x is greater than 4. Thank you for listening, math learners.